All right, guys, let's jump back into our right triangle lesson here. We kind of ended up, we talked about the special right triangles, which we'll review a little bit. Remember the 30, 60, 90, and then the 45, 45, 90. And we were able to find the side lengths by just, if we knew one side, right, we kind of knew those patterns to find the other two sides. And of course, you always have the Pythagorean theorem, but that kind of requires that you would know two sides. You could find the third. So using what's called trig ratios, sine, cosine, and tangent, you're able to find sides of basically any right triangle, as well as find angles, which we'll do in another video. But let me just give a quick definition of what each of these are. These are the three main ones. Again, sine is abbreviated SIN, and then cosine and tangent. And the way these work are, if you think about a right triangle, let's say we have any old right triangle here, okay, does not have to be a special right triangle. Theta, you'll see the variable here, that's just a commonly used variable for angles, but it's just like an x or anything. It's just like any other variable. And basically the idea is from that angle, like that's our reference angle, we have the three different side lengths. Of course, the hypotenuse is always here. The opposite, okay, from where I drew theta, the opposite's on the other side of the triangle. And then the third side, the one that's like close to or next to the angle, we use the term adjacent to describe that one, so ADJ. And basically the way this works is that the sine, the cosine, and the tangent is just going to be a ratio, okay, like we studied in the last chapter, just like a fraction, of two of these sides here. So the way it works is sine will always be the opposite side length over the hypotenuse. Cosine will always be the adjacent side length over the hypotenuse. And tangent will always be the opposite over the adjacent. Okay, so if you take a look at the first letters of each of those, there's this saying, or this little memory device, looking at those first letters, of SO, okay, for sine being opposite over hypotenuse. CA, C is cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So SOH CAH TOA, if you ever hear that saying, it's just kind of a way to remember these three ratios. Okay, so let's look at some examples with some numbers, but those are kind of like formulas, or those are just like always going to be that way. So they will need to be memorized. You can use the SOH CAH TOA trick, or once you do a few, you'll kind of get it down. But let's see what it can do for us. Okay, these ratios right here are obviously key. You'll be given an angle measure. Okay, they may even give you more than one. If you know both other angles, you can use either one. And then decide, based on the angle you're using, which of the sides are the ones you're given or trying to find, right? And generally it will be two of the three, and you'll be able to figure out which ratio, which calculator command you need to use to solve these. All right, so that's a brief intro. Again, there's tons of other videos if you just look up finding sides in right triangles or SOH CAH TOA. There's going to be a ton of videos with extra examples, and we'll keep working on it. But yeah, that's a little intro for you there. So let's use one of the special right triangles to do our first example, and then we'll do an example when it's not a special triangle. And the ones that are not a special right triangle, you really just need a calculator to solve. But the special right triangle, since we know some things about the side lengths, if you remember, we talked about how in a 45, 45, 90, the legs are going to be the same, right? So we'll just call them both x. And we showed if you use Pythagorean theorem and simplify, that the hypotenuse will always be x times the square root of 2. Okay, so what that does for us, if I ask you for the sine, okay, of 45 degrees, we know sine, again, is opposite over hypotenuse. Okay, and we can look at the triangle now and think about, all right, from the 45-degree angle, and it doesn't matter which one we use, right? There's two 45-degree angles. If you notice in both of them, the opposite side length is x, and the hypotenuse, no matter what, is x times the square root of 2. And then if you just remember, we can't leave a square root in the denominator, so the way we rationalize that is called, is we multiply top and bottom by the square root of 2. And we end up getting x times the square root of 2 over x times the square root of 2 times the square root of 2 is the square root of 4, right, which is just 2. So the denominator becomes 2x. And then what ends up happening is the x's here can kind of cancel each other out, right? X divided by x. So the leftover terms are just the square root of 2 over 2. And so that is the sine of 45 degrees. Okay, the exact value of it, it's the square root of 2 over 2. Okay, if you were to pull out a calculator, which we'll be doing in a minute, and you type in sine 45 and press enter, you're going to see some decimal. But the decimal, it might say like 0.707. That is the square root of 2 divided by 2. Okay, the good news with the 45/45/90s, that kind of lightens the workload a little bit, is that the cosine of 45 degrees, we know cosine is always the adjacent leg over the hypotenuse, actually equals the exact same thing, right? Because imagine, let's say you're using that 45-degree angle. Here's your adjacent side. Here's your hypotenuse. So it ends up being, again, the adjacent side, x, over the hypotenuse, x root 2, which is exactly the same thing we had up here. So simplifying in the same steps, you get the square root of 2 over 2 again. So the sine and cosine of 45 are both equal to each other. They're both root 2 over 2. Okay, and probably the best one, the tangent of 45 degrees. Right, we know tangent is opposite over adjacent. Well, again, let's use that 45-degree angle. The opposite side would be down here. And the adjacent is the one we used x before. So the opposite and the adjacent are both x. X over x is just 1. Okay, so the tangent of 45 degrees equals 1. And try it in a calculator, tan 45. If it's not giving you 1, you need to check one thing. There's a mode. We need to be in degree mode. Because our angle measures, we are in degrees at this point. There's another one called radians, which we'll get into more in Algebra 2 and Pre-Calc and beyond. But for now, we're going to stick with degree mode. Radians is the one that's used later on, if I may have misspoke. But degree mode for now. So on your calculator, look for a mode button, or you may see it on your phone. If you're using your phone calculator, there may be a degree radian button somewhere. So rule. Okay, so let's look at an example here where this is not a special right triangle. You know, it's close to a 30, 60, 90, but it's not exact. And even if it was, you can still use this method we're about to do to solve these problems, but you will definitely need a calculator. Okay, so let's take a look at what we have given to us. We have a 62-degree angle, okay, and from that angle, okay, we of course have the hypotenuse over here. The 10 on the bottom, that's the adjacent side, because from that 62-degree angle, the opposite side would be over here. Now, if you notice, we're not using the opposite side at all. So if you think about the SOH CAH TOA, right, we need to see which one does not use the opposite side in there, right? So sine has opposite in it, tangent has opposite in it. So in this problem, we're just dealing with adjacent and hypotenuse. So we're going to use cosine. That's how you choose which ratio to use. And what we're going to do is look at the cosine. Our angle is 62 degrees. Okay, so the cosine is 62 degrees, which again, you can find that value on a calculator. It's just going to be some decimal. We know, though, that it needs to equal the adjacent over the hypotenuse. So make sure you write it in the correct order. For our triangle, that's 10 over x. Okay, so what we're going to do, we want to solve for x. So since it's in the denominator right now, we're going to multiply both sides by x. Okay, x times whatever the cosine of 62 is. Again, what your calculator is going to know. Must equal 10. And then one more step to get x by itself. We're going to divide both sides by the cosine of 62. And again, your calculator is going to handle this. Don't freak out like I don't know what that is. But x is going to equal 10 divided by whatever the cosine of 62 is. Okay, so it just turns into a calculator problem. So again, just make sure you're in the correct mode, and I'm literally just pressing 10 and then divided by cosine of 62. Okay, and that's getting me an answer of 21.3. Okay, so that would be the side length. Okay, that one's the hypotenuse in this example. it would be 21.3 inches or centimeters or whatever unit it might be. Okay, so let's do one more example. Let's say we have this triangle here. There's a 38-degree angle. Two sides are given. Let's see which sides are they. So based on this triangle, if that's kind of the angle we're using as reference, again, the 3 is the hypotenuse. The x is the adjacent again. It just so happens to be adjacent and hypotenuse again. So we're going to use cosine again, but it could be any of the 3. But for this problem, we must use cosine, so we're going to write ourselves a little equation. I know that it's always the cosine of an angle equals its adjacent side, in this case is x, over the hypotenuse. So what we're going to do in this case is going to be a little simpler. All we have to do is multiply both sides by 3. You're always going to multiply by whatever's in the denominator. Okay, and that'll cancel out that. So we're going to have 3 times the cosine of, 60, 38 degrees will equal x. Okay, and we're just simply going to go into a calculator. 3 times the cosine of 38. That's going to give me 2.36. Okay, again, it just has to be done on a calculator. That's going to be our side length down here, our little adjacent side. Okay, so again, just to recap, you want to go back to the